Hey guys, I'm very excited for another episode of Show About Science. This is your host, Nate, and today we are going to be talking about ice cream. I've been doing a lot of research for this episode with my mouth. It's going to be an awesome episode, so stay tuned. So, I think I'm going to order vanilla and do you have cookie dough?
I do have cookie dough.
Okay then, cookie dough too.
Sure. Do you want me to put it in a cup for you? Do you want it in a cone? Do you want it in a sundae, as a shake?
Could I have the vanilla a shake and the cookie dough in a cup?
Sure. Do you want me to give you like a little kid size or you want a big boy size?
Big size.
Big size? Okay. Do you want me to add any sprinkles to that too? Or
No.
No? Anything else for you today, sweetie?
When you're conducting ice cream science research, you always order the big size, skip the sprinkles, and be sure to do it on Sundays because, well, Sunday is the day most people eat their ice cream. It's an ice creamy science fact. It would be so much fun to be an ice cream scientist. I could just imagine what it would be like. Nom, 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 nom. Ooh, new discovery about ice cream. Let me eat up that new discovery. Nom, 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 nom. After finishing up all this yummy research, I was finally ready to call today's guest Rich, a food engineer from the University of Wisconsin-Madison. And I was really excited to learn about the work that goes into being an ice cream scientist.
Nate, this is Rich.
Hi, Rich.
So you're interested in ice cream?
Yeah, welcome to the show. Could you introduce yourself?
Yes, I am Professor Rich Hartel at the University of Wisconsin-Madison.
So, everyone here knows what ice cream is. What's the science behind ice cream?
That's such a broad question. Every aspect of ice cream is science-based. So let me start by talking about what ice cream is from a physical standpoint. We all know how delicious it is, but what makes it so delicious are all of the structures that we form in ice cream. So ice cream has ice crystals, right? And the science behind how those are formed and how we control them to give us the right sensory properties is pretty important. Ice cream is also a foam. It means that there's air cells or air bubbles that are embedded within that frozen matrix, and they also play an important role in the sensory experience of eating the ice cream. And then ice cream is also an emulsion. Cream, one of the main ingredients, has a lot of small fat globules, and in the process of making ice cream, those fat globules go from being single individual entities to being clusters. And again, those clusters of fat globules have an important role in how ice cream is perceived. So each of those elements, and then the fourth element really is the continuous phase of ice cream that holds that all together. All of them have important science principles that control them.
Why do people like ice cream so much?
Well, why do you like ice cream so much?
The sweetness.
So sweetness is one thing, but there's a lot of things that are sweet. So there's coldness. It's often best in the summertime.
Yeah.
And when the ice melts, it takes heat out of the environment, so it cools your mouth down. And that's another incredibly good sensory property of ice cream. So sweetness, the coolness, anything about the particular flavors that's of interest?
In a while we'll get to that, but does ice cream make you hotter overall?
Does it make you hotter? So if you eat ice cream in the summertime, will you actually feel warmer than if you didn't eat ice cream? I don't think so.
Okay, so what is the most favorited type of ice cream?
Well, isn't that an individual thing? So everybody has their own favorite flavor of ice cream.
But what do most people think is good?
Well, the number one selling ice cream, which may be a little bit different than what the favorite is, but the number one selling ice cream flavor is vanilla.
And that's the number one favorite, too.
But favorite in terms of what?
Most people's favorite.
But if you go to an ice cream shop and buy an ice cream, will you order vanilla ice cream?
I would.
Okay. Not most people. So we have an ice cream store here in our building, and the ice cream is made here in the building as well. And I guarantee you that very few people, when they order an ice cream cone, order vanilla ice cream. So they're always ordering some kind of other flavor like Blue Moon or cookie dough, something like that. So you must be unique.
Yeah. So, can you make ice cream that never melts?
No, because the ice will melt if you keep it at warm temperatures. But if you ask the question, can you make ice cream that doesn't collapse when it melts? The answer to that is yes, because of those structures, the fat globules and air bubbles that we create. So there are some ice creams that when you sit them out at room temperature, they melt and flow into a puddle. And there are other ice creams that when you put them on the counter to melt, the ice will melt, but because of the structures, it won't collapse and flow. It'll actually still retain its shape. If you remember, there was a concern about Walmart ice cream sandwiches a while back because they didn't melt, but that's sort of a misnomer because the ice really did melt. It's just that they had enough structure that they didn't collapse.
Yeah, because in the videos you could see them melting, but they definitely didn't collapse.
Right, so there's a very different characteristic between the ice melting, which they did because it was warm out, and then the ice cream collapsing. So again, the structures that we form in ice cream, in this case particularly the air cells and fat globule clusters, provide a network that prevents, even though the ice is melted, it prevents the continuous phase from collapsing. And so it looks like it hasn't melted because it hasn't changed. But of course the ice really has melted.
Why is it concerning if ice cream doesn't melt?
I think it's not concern to me. I understand. So I have done a survey of the ice cream products out in the commercial marketplace, and I know which ones will stand up when they melt and which ones will collapse when they melt. And I also know that that's related to these structures in the ice cream. Now, those structures in ice cream change how the perception of the sensory aspect of the ice cream. But people don't always think about that, not even the people that make ice cream, I don't think. So that's part of the science of ice cream, is to understand the structures and relate that to the properties of the ice cream, and particularly the sensory properties of the ice cream.
Can ice cream be shaped into a cube?
Yes. In fact, the old bricks of ice cream, the half-gallon containers, used to come in, well, they weren't quite cubes, they were more rectangles, but basically it just depends on how the shape of the package is. So most ice cream is made by freezing the ice partially so that it's basically soft-serve ice cream that comes out of the freezer, and then that goes into a package, and because it's still fluid enough, it fills the shape of the package. And then that package goes into a hardening tunnel to set the rest of the ice. So whatever shape you create is a function of the package that you use.
So how can you make ice cream with a tube and a fire extinguisher and some other materials, including ice cream mix?
Well, so a fire extinguisher depends on which type of fire extinguisher you use, but one of them is a CO2 base, and I assume that's what you mean.
Yeah.
And when you expand CO2, you get a cooling effect, and that cooling effect can help freeze. So any kind of refrigeration effect from something like a CO2 cylinder where it's changing from a liquid to a gas has a cooling effect, and if you apply that cooling effect correctly, you can freeze things. And the same is true with liquid nitrogen ice cream, right? So you pour liquid nitrogen into an ice cream mix, and the liquid nitrogen evaporates, and that evaporation process gives you a refrigeration effect, and it cools the ice cream mix, and that's what causes it to freeze. Same thing for a CO2 fire extinguisher.
Can ice cream be used to power machines?
As far as I know, it hasn't been, but that's an interesting question. So could we use the cooling effect? So when ice cream melts, it actually takes heat out of the environment, which is part of why you get that cooling effect in your mouth. So could you apply that cooling effect somehow to power some kind of motor? That's a good question, beyond my ability to answer.
Sounds like I need to do some more research. Thank you for being on the show, Rich.
Thank you.
There you have it, folks. The show about science is complete. Music on today's episode was written by the amazing Breakmaster Cylinder. And our theme music was composed by Jeff and Teresa Brooks. Dad, you can shut the recorder off so we can go get some more ice cream. For the newest episodes of the show about science, download the Pin app or go to pinna.fm/promo.